Hi all. Thank you all for joining me today. I'm really glad to see so many people come out here. I don't know, who was here before, last year at FrosCon? Any of you? Well, yeah, just were you at the conference last year? Yeah? Are you guys enjoying it today? Yeah? Okay. Me too. I always love this conference. I think it's a really friendly, environment. I always love, attending, but also speaking. Last year, I presented Huey, which is a pet project I've been working on. And at the time I thought it was pretty okay-ish and pretty functional, but at FrosCon, I got a lot of questions from the audience, and or at least a lot. I got good questions from the audience, and that led to a couple of new features. And today I'm here to basically do the same kind of presentation as last year, but highlighting some of the features that came out of FrosCon last year. So if you see anything or think anything can be improved, don't be shy, just talk. And maybe next year I can do the same talk, but with your features in there. So, okay, let's get started. So, Huey. We're going to talk about Huey, the pet project, and it's about blazing fast analytics on Parquet, CSV, JSON in your browser. Now, I know I don't like the adjectives blazing fast and that kind of stuff, but it's kind of like the template for this kinds of things. So, okay, so I'm Roland Bouwman. I work as a chief software engineer for EPAM Systems in the Netherlands. EPAM is a large service provider. We do all kinds of stuff, and I'm in the data analytics branch. I work as a consultant at customers, usually with something data warehousing, analytics, BI related, but it's quite broad, right? Sometimes you talk to customers and try to get their requirements, and sometimes I'm just building tools, and that's actually what I do a lot of the time. But what I like doing, building tools and building stuff. Now, Huey is not something that I created for my employer. It's really an open source pet project, but we happen to use it at our customers, and it's like one of those tools that can just fly under the radar and outside of the attention of the IT department, which makes it a nice thing, I think. You can find me on LinkedIn, GitHub, on my blog, and email me if you need to. If you have any questions during the presentation, just raise your hand, and I'll figure out if it's useful to answer it now or wait until later. And here we go. Okay, so what's Huey? Oh yeah, this is an experiment. I never did this before, those hip QR codes. I mean, maybe they were hip already 20 years ago, but now I'm trying it myself. If I use a link or something that I think is you might want to store for reference, I have the QR code up there, and you can just visit it and see if it is useful for you. Now, in this case, it's QR code to the GitHub repository of Huey, of my project. So what is it? It's a browser-based app, a web page, basically. And you can use it to explore and analyze data, mostly files, but we'll get into that in details a little bit later. And it comes with what I think is a pretty intuitive and powerful query builder, and the results are laid out as a pivot table. It's pretty basic stuff, but very useful, I think. And then it lets you export the results and share your findings, share your analyses. And what's so special about it? Well, nothing is that special about it, but there's a couple of key themes that I try to do around this tool that make it, I think, a little bit nicer or better, or at least more unique than other tools in this genre. First of all, I would say it's easy, because you just download it and you can get going. You don't need to put it on a server or whatever. It's just a web page. You open your browser, and then you have the app. That's all there is needed for it. It's safe, because we see these modern web applications that are packed with all these libraries coming from everywhere and nowhere, and you don't. Well, I think it's very hard to track down what's going on there. Huey has almost zero dependencies. It relies on a very important component called DuckDB, which I'm going to talk about a little bit later. So that's a dependency that I cannot, deliver myself. And it uses icons from an icon font. And those are the only two external dependencies it has. The rest is just vanilla JavaScript code and HTML and CSS. So in that sense, it's safe. Because it doesn't do all kinds of requests to the internet and doesn't share your data and that kind of stuff. So it's secure. The data that you analyze with Huey stays on your machine. So it comes from your machine, stays on your machine. We don't do any requests to an external API. We don't send the data anywhere. It stays on your device. And what is, I think, truly unique, and that's not so much about Huey, but more about the tool that I use underneath. It's powered by DuckDB, or to be specific, DuckDB WASM, which is basically the library that allows you to run DuckDB in your browser. We're going to talk about DuckDB a lot more later on, but for now, that is why the tool is good. So last year I said it as well, now I say it again. If you see anything that's good about Huey, it's probably because of DuckDB. If you see anything that's bad about Huey, that's probably because of me. And then you should let me know, because I'm going to try and improve it. Last of all, of course, it's free. It's free as in beer, free as in speech. It uses an MIT license, just like DuckDB, which means that you can pretty much do anything with it. You can, copy it, you can install it in your own software, ship it, whatever. You're free to do so. Okay, so I talked about DuckDB. Now, what is DuckDB? DuckDB is essentially a database management system, but it's a special one because there's of course all kinds of categories that you can use to categorize database management systems. DuckDB is unique in the sense that it's geared towards OLAP, so analytics, and it's in process, so it's embedded. Now, anybody of you used SQLite before? Yeah, okay. So DuckDB is kind of like SQLite, but then for analytics. That's probably the best way to express it. And what does that mean? So, first of all, it's simple. You can really easily install and deploy DuckDB. And DuckDB itself also has no external dependencies. DuckDB comes with a plugin system, so you can plug stuff in, and that, in that sense, are externals. But the core product itself does not have any external dependencies or whatever. So you just download and run. No install, no complicated things. It's it's really fast for what it does. So it uses internally it uses a columnar engine to process the data, and it tries to parallelize your workload across the course of your local machine as much as possible, and you can configure that and so on. And all the data operations are written as much as is possible using a streaming interface. So this means that DuckDB can process data that is data sets that are larger than your main memory, which is of course useful. So that's why it's fast. Now, it is very portable and easy to integrate. So they distribute binaries for all kinds of major hardware platforms. And there's a whole bunch of drivers for all the different kind of languages that you might want to use it for. So it's really easy to just get started with it once you have the product, and use it to build your application on top of it. DuckDB is extensible, so there's a whole plugin system there that you can use, like from a very low level to a very high level. You can build an extension that does something useful, and this really goes from like somebody built an extension for like GIS data types. That's one very low level specific thing, up until there's a whole UI supporting notebook interface also built as an extension. So there's a whole range of things you can do to extend the abilities of DuckDB. And there's a whole bunch of extensions that are already part of the core that you can just download safely from a registered repository. And there's a whole community around it that also creates plugins. Very interesting architecture, because it allows for a lot of things, and almost every month there's a new kind of extension where you think like, oh wow, this is also possible. So it's a great thing to check out. It's pretty rich in features. So of course it's in the end it's a relational database system that supports SQL. But it's pretty up to date with the dialect. So it's basically Postgres dialect. So it means that's very up to date, very new features are in there. And then DuckDB also adds some features that make it even easier to use. So they kind of optimize the SQL dialect for interactive use, which is nice for data scientists and that kind of applications. Some of the other features that are kind of unrelational database-ish is that it allows you to work with all kinds of files and all kinds of formats of data, like JSON and that kind of thing. And there's, of course, other databases that do that as well. But I think the way that the SQL dialect from DuckDB integrates these features and exposes them makes it very easy to use them. Even if it would not be your first nature to use them. So I think they really done that well, and it's almost a joy to work with those kinds of strange, unrelational formats when you use DuckDB. So DuckDB for me is like a Swiss Army knife that I use almost every day for solving things that I could not solve otherwise, or only at great expense and great effort. Now, of course, DuckDB is free because, again, that's open source, MIT license, so you can are free to do pretty much anything with it. And this, of course, helps to reduce the friction in using it. Now, how could you use DuckDB? So, first of all, just downloading it and running it as a command line executable, doing all kinds of dirty data cleaning tasks and things, ad hoc stuff. Swiss Army knife stuff. That is something. You can also use it to build real, actual data integration pipelines. If you want to, you can embed it in all kinds of workbooks as well, and people do. There's JDBC driver, ODBC driver, so you can actually do a Power BI report on top of it using one of those drivers. Stuff like Tableau, that all works on top of DuckDB. And then, of course, there's all these drivers, official drivers for Python, R, Node.js, Rust, Go, and so on, C, C++. And then there's the WASM, which is the WebAssembly, which we use for Huey. So that, in a nutshell, is DuckDB. There's a QR code to their website. You can check it out. Great documentation as well. Friendly community. You can it's easy to contribute documentation or contribute bugs. They appreciate it. They like it. Oh yeah, that's one of the things I should say. DuckDB comes out of the Center for Computer Science in Amsterdam, which is a very it might not be that well known, but in the branch in the database. The development world. It's a very renowned institute, which has created all kinds of applications and database technologies that are now widely used. People that built Snowflake were educated there. They created MonadDB at some point, the first open source columnar database. Vector-wise, it's all coming out of that institute. So it's like a powerhouse. And it happens to be in Amsterdam, but of course it's a very international institute with researchers from everywhere in the world. And DuckDB comes out of that whole institute. Okay. So DuckDB fits into this whole thing, what they call a small data trend. And the way to understand this is, first of all, when you say, okay, is a small data trend, when is something a trend? Who decides that? There's a group of people in San Francisco, and they've written a manifesto. I'm always a little bit suspicious when people talk about things in these terms, because it's very political, right? But what it really means is that, we live in this world where we had this whole big data, movement, and everybody was doing big data, and everybody was always trying to say, when you build something, it has to be scalable, it has to be flexible, it has to be this, has to be that, has to run on clusters in the cloud, and all that kind of stuff. And we've had 10 years of that, and it's very tiring, right? Because if you want to do anything at all, it always gets immediately very complicated with all these multi-node distributed systems. And the question is, do you really need that, right? And for many of the customers that I've seen, most of them have migrated their infrastructure to these, resistant, parallel, distributed cloud database platforms. but their data set is not really, they don't really need that, right? They could have also done that with a bigger computer. And yeah, I think this whole big data trend, we are now kind of in this post-big data world, right? Customers have already upgraded their machines and their systems to that. But a lot of the work that you do doesn't really require those kinds of architectures, and you can easily get by with a much smaller and much simpler solution. And that's where DuckDB comes in, because it doesn't get simpler than that. It's just the executable, and then you just point it to the data that you want to process. You start processing it, and you do something with the result. So no waiting for clusters and no clusters that you have to pay for. It's just your own machine and your own problem, and that's it. This is another place where a solution like DuckDB can help. If you find that, for example, if you're doing Databricks a lot, and people are working with all these data lakes and Parquet files and that kind of stuff, and they need to do sometimes just simple things, just do a preview of the data so they know how they can develop an algorithm or whatever. You start up the Databricks cluster, you do the preview, you're done. In the end, it all adds up, right? It costs money to do that kind of thing. With DuckDB, you can always do all those things locally for free. Well, I mean, for whatever your computer costs, right? And it makes things simpler. So that's really, this whole small data trend is basically a way of saying you don't need all that complicated architecture. You can do a lot of stuff on your own machine. And of course, in those 10 years that we had the big data trend, our machines have become a lot more powerful as well. So we do, for our customers, process serious large data sets, and often we start out with a laptop, and really it's like that the IT department at some point wants to deploy it on a server, but it really wasn't necessary, right? We could have just be doing it on our own laptops, because again, sure, the data is big, but if it fits on your laptop, you can probably deal with it with DuckDB. Okay, there is a little fact behind the small data trend. This is from George Fraser from Fivetran, who is a service provider that, basically they offer data warehousing as a SaaS solution. And they took a look at how people are using their data warehouses. So people have built all these like Snowflake, or in this case Redshift data warehouses. And these are database systems, but are they using them as database systems? Turns out they aren't. They are using them as ETL tools. So to process, to aggregate data. And if they look at the data set size that people are using, you see it in the graph there on the bottom axis, you see the size. You see there's like a peak, in the 30, 50 megabyte range, right? So it might be that the total data set of a customer is really large, but at any point in time, you're processing only a slice of it. Probably the most recent slice, because that's the most important one. So this is from George Fraser, who is not into writing manifestos, who was not into defining what a trend is. They just looked at what their customers are doing with these advanced distributed data warehouses. And it turns out that probably they could have done most of that job, on a much more cheap infrastructure, a much more simpler system. Something to think about. I'm not saying you should, immediately turn around your whole infrastructure, but it's something to think about. Okay, now let's go back to Huey. So what does a Huey workflow look like? First of all, we need to find some data that we want to analyze. And typically that would be a file. Or it could be from a URL. That's also fine. And right now, Huey can read CSV, Parquet, JSON, Microsoft Excel, and DuckDB database files. Basically, it's the set that DuckDB supports out of the box. Well, then once you get your data acquired, it will create a model for that. And it sounds really fancy, but what it just means is that it just gives you the columns with some metadata. What data type is it most likely, as well as some, let's say, calculations they're not executed, immediately. They're executed when you ask for them, but it already stores them for you and puts them, in place so you can just use them to start analyzing your data. So you inspect the data model, you look a little bit at like what columns are there, what is kind of the statistics for those columns, and you kind of formulate your question. And then to answer your question, you build a query. And building a query, in this case, means taking items from the data model and putting them on query access in the query builder. And you can do that with point and click or drag and drop. All those kinds of paradigms are there. And you can add filters, you can add totals, and then the results you can just either look at them or you can export them to a clipboard or file, and or you can share them. And the query state itself is immediately reflected in the URL, so that you can share the URL and share that with your colleague. They can immediately open the same query as you do. We're going to show that in the demo. So I prepared a demo. There's 3 links over here. One of them is to, you're all on the phone now. Huey does not work well on a phone, so that is something that we will see in a minute why it also doesn't make that much sense. But if you have a laptop and you want to follow along, feel free to do so. The first one is the download of the source. You can do that if you want a local copy of it. There's also a live demo site, which means that you don't need to install anything. You can just do it on the site. But then you have to trust me that the site is safe and that your data is not going to go get lost. And there's a link to a data set that you can use, which is just a URL. If you need a QR code, Yes. The live demo and the URL for the dataset. Or if you have your own dataset, that's also fine. Okay, I'm gonna move on, and if anybody needs help setting up later on, you can always find me after the talk. Okay, so I'm just gonna leave the presentation for a second. And I'm just going to show you first the project website. So this is the website. So github.com rpbouwman/Huey. People sometimes ask me, like, what is the name Huey? Why is it called Huey? Well, it's because it's DuckDB, and Huey, Louie, and Dewey are like the nephews of Donald Duck. Sorry, there's questions. Oh, I'm sorry. Thank you. Thank you so much. Yeah. Okay, so this is the GitHub website. The reason why I'm showing it to you is because there's a few things in here that you might help you when you want to check it out. So first of all, there's a README, and that is also immediately the documentation. So that's and it's one README. There's no. I mean, it's a longish one, but it's not super long. It's just a couple of pages, and it explains all the features in there. On that page as well is the link to the live demo, so we can visit it in a second. So this is like the lowest friction way of checking it out. You don't need to install anything, don't need to download anything. You can just click the link and get going. The code, of course, is over here. If you want to check out the code, you can either just do a checkout with Git or download the zip if you want to just run locally. There's releases. I have a bunch of releases over here. The latest release is always also visible over there. So if you want to have a stable product, that would be the one that you would go for. And other than that, we can just get going. I already got it over here. And the first thing we notice is that it's just the file, right? I just downloaded and I just clicked the source index.html and it runs in my browser. There's no server here. It's just the web page, nothing more. Now, I got a script prepared. So first we're going to get the dataset. In this case, the dataset is just a URL. So let me get it over here. So the interface is initially quite minimalistic, not much to see here. We can upload the dataset or we can upload the URL. And that's what I'm going to do now. This is an open dataset for flights in LA City. Yeah. So we give in the URL. It starts uploading. It's done pretty quickly because it's a small dataset. Yeah, this is your first step. So now you've got the data acquired, and here we see the attribute UI. So this tab appeared after that we added the data, and this is basically the data model. I already said that data model sounds very fancy, but initially it's just a set of columns. And we can see a couple of things. So we see, of course, the names of the columns as they appear in the data file. We see icons, which tell something about the data type that it is. And there's also a tooltip that explains the DuckDB data type that is used to represent the data in that column. And we have a couple of buttons and so on, and some expanders. I'm going to talk about that in a second. Now, the first thing you probably want to do is you just want to get a feel for what data is it. What does it look like? Now, this is a feature that came out of the talk from last year. People said, yeah, I want to have that data preview. And we expanded a little bit on that because basically this quick query menu gives you a set of canned queries, things that you want to do just always to just explore your data a little bit. Right now there's two available, one for column statistics and one for the data preview. If you just do column statistics, what happens is that some of these items are placed here on this axis over here, and we get the result. And we get the result immediately because if we've got auto run on. What we see here is it took the data extract date, the column over here, and it took a couple of metrics. It took the minimum, and it took the maximum, and it took the count and the distinct count. And this pair of 4 metrics we see for each of the columns. And this gives us a quick feel of what kind of data is in the data set as a whole. And what does it tell you? It tells you, for example, that okay, we've got so many date values, but only 1 out of 4 of them are unique, right? So it tells you something a little bit about the entropy of your data set. How many different values have you got? How many nulls are there? And we see the minimum and the maximum, so we get a feel for the range. So we see, for example, the data extract rate runs from 2018 to 2023. And the actual reporting period, so the actual date when the events happened, what this dataset is about, runs from 2006 to 2023. And then we see a couple of very low cardinality types. For example, the flight type, only 2 values, charter and scheduled. And we see a similar thing for the arrival departure, it's just arrival or departure, and domestic and international. Now, just a quick idea of what the data looks like. Now, if we want to see the actual rows, we have a quick query for that as well. And that's this one, data preview. And that really, what that does is it pushes the row number on the rows column, and all the other ones get shown as cells. And this is basically the first 100 rows of the data set, so we can just really look into what is there. Okay, so this would be your normal first couple of steps when you're analyzing data. Now, of course, we want to do something like more analytic. And what is also always a paradigm with these analytical queries is that you kind of divide the columns that you have in 2 different categories, in 2 different types. So you have the things that we call dimensions and the things that we call metrics. And the metrics would be some quantifiable unit, something that you count or something that you can sum up about the business process that is stored in this data. And then all the other columns are part of the context where that measurement was done. Now, if we look at the data over here, we see that the flight ops count is a numerical thing, so that is a quantifiable thing. It could, I mean, it's an integer, so it could also be an ID, but in this case, flight ops count, the name strongly suggests that it's the number of flight operations, right? That is what we're gonna look at. So that's a metric. And all the other things have to do with time. In this case, the data extract date, reporting period date, and the flight type and the arrival or departure or domestic international. Those are really dimensions about the context about those flights. Now let's clear it. And now let's start by putting that flight ops count on the cells, because that's what you do. If you have metrics, you put them on the cells axis, because that's in the intersections of your pivot table, and that would be an aggregate, something that you sum up or that you count. Now we see that there's these buttons that allows us to put the things on the axis, but we don't see a button for the flight ops count, and that's because it's in here. Because right now this is just the column itself, right? I can put the column on the rows. But that's not really useful, because we want to see not individual counts on the whole. We want to sum it up over the context. Now to do that, we need to find an aggregate, and those are inside. So we expand the node, and here we see a couple of aggregates that are already there. In this case, our column value is already a count, so we don't want to count that again. We just want to sum that up. So if we do that, we see that we now have a total of 900,000, something flight operations in total. And this is like just all the flights, right? All the flights without any context. Now, if we want to see some context, we should add dimensions. And in this case, I'm going to take flight type. I'm going to put that on the rows. So now we see charter versus scheduled, and we see the flight op count, slicing it up into these two different categories. And we can do the same thing for arrival and departure, but we do that along the other axis, like this. And now we get this typical cross-tab analysis, type of analysis, by just what we would call slicing and dicing. Now you see, I'm using these buttons over here to move them. Once the items are on the axis, we can move the axes themselves around. You can see if I hover over the icon over here, it tells you that you can flip them around, right? So I can do that, and then the result just pivots around. It doesn't change the information, just change the layout. We can do the same, or more or less the same, for the cells, because you see that the cells are these things in the intersections, but the headers of the cells are now along the columns. But we can flip that around as well. So now the headers come at the row rather than the columns. Now again, that doesn't change the information, just changes the layout. Now we can also, I just use the point and click method of adding them, but we can also use drag and drop. So I can just drag the item, and you can see I cannot drop it again on the rows axis because it's already there. I can also not drag it to the cells axis because it's not an aggregate, but I can drag it to the columns one. And now we have them both. And once you have multiple items there, you see there's a couple of buttons here that you can use to flip them around, or you can use drag and drop for that as well. It's just what you like, right? So sometimes you have a pointing device and you want to drag and drop, and some people just don't want to do that. They have a tablet and they just want to use the fingers. You can all do that. It doesn't matter. Okay, now we've got flight type, arrival, departure now on the columns, and now the rows. And now we want to look at something like the date. The when did it happen? Now we could just add the reporting period. The reporting period to the rows axis, and if we do that, we get really the date values, right? And those are timestamps. So you get a huge spread of all these dates, and it's not so useful, right? Because what you want to do is you want to kind of navigate the data. You want to treat it like a hierarchy. Now to do that, and this is where that model concept comes in. Let me just remove that item. If we expand the reporting period, we see that, yeah, because it's a timestamp, we get these folders with date fields and time fields. So Huey has already, seen because it's date, it might be useful to, report on the year or the quarter or the month. So we can treat those as individual columns, basically. Now, let's do that. So we're going to drag the year there. And now we want to drag the month name, or the short name. And then you get this feature where, because it's 2006 and we have all these months there, the 2006 value repeats, but yeah, we see this little mark indicating that, it's repeating. Yeah, you can configure how that looks, but the point of that is to not repeat the data so that it doesn't get cluttered, right? So you get like a nice clean view of the data there. Now, okay, so we started with this big count of all the flight operations, and then we started adding, attributes, slicing it in little parts, and now we kind of lose the oversight, right? It would be nice to kind of also have totals to see like how do the different parts compare to the whole. Now to do that we have totals, and that's these buttons over there. So if we add it, let's add the totals for the month and totals for the arrival departure. Then you see that, okay, for each of these categories we get this line over here that gives us the total. Right now in this case the totals appear on top, but we can configure it over here and control if it shows before or after the whole set, right? So you can just adjust that to your liking. We have the totals on the months. We see those over here, and it's sometimes a bit confusing because I clicked on the month, and that means that for the month we get a total. You would some people think that it should be on the year level, but there's no reason that. I mean, there could also be a quarter before that, right? So total over month means that you get a total row along with the months to show the total of the months. Now we have the same then for the arrival departure. If we add the other totals as well, that's also possible, of course. Then in the end, if we scroll all the way down, all the way to the right, we then here have again our grand total of everything together. Oh wait, actually I don't see the. I'm sorry. That should also be on the top. Yeah, here we go. Here's the. Wait. Yeah, over here. Our grand total. Okay. There's one operation that I didn't show yet, because we've now looked at all the data, the entire data set. It's not a big data set, but anyway. One thing that we didn't yet do is what you would call slice. And slice means that you're like looking at only a portion of the data. We have one attribute left, so let's try that, and we can add it to the filter. This opens the filter dialog, and what this does is, and right now we only have 2 values, so it gives you here all the values that are in that column, and if I click them, it gets added to this list over here, and then when I apply it, in this case our filter operation is include. So I now just included all the values, right? Which is a little bit silly because we already had all the values, but I wanted to show you this. The filter is a little bit special because all these axes are exclusive, right? I can only have an item either on the columns or on the rows axis, but not both at the same time. And the filter is different. I can put any item that is also in the rows or in the columns also on the filter. Because, just that you're filtering on something doesn't mean that you don't want to show it, right? So that is the reason why that works. And we can also expand it and give you a little, easier interface to just enable or disable some of these values, which gives you a kind of a dashboard feel, right? But very ad hoc, like not all designed and stuff. It's just a very quick way to, be able to browse between these results. Okay, so these are the basic operations that you can do with Huey. One of the things that I didn't mention yet is whenever we change the query, we see the results, of course, change, but the URL also changes. And what happens is each time you change the query, this URL gets updated, and we store an entry in the browser history. And this allows you to do undo and redo, because now I can go back, and the entire history that we just did to build up the query, you can just replay it. And so you can prepare your presentation in this way, by preparing your analysis in this way, and then browse through it to present it. And you can also, of course, bookmark it. If we do that, I'm not sure exactly where it's going to end up. Over here. Okay, so let's try that then. If I kill it now, and I go, and I visit the bookmark, then it just grabs the entire set. And in this case it works because we took the dataset from a URL. If we take a local dataset, it will prompt you and say, oh, where's my data? Because of course the data itself is not in the URL. Okay. Okay, any questions so far? Something, yeah, go ahead. Yeah. Yeah. Yeah, we're gonna go there. Let's do that. I'm gonna leave this query over here, and we're gonna find some Parquet stuff. Okay, give me 1 second. I have here the taxi dataset that everybody knows and loves for this stuff. Taxi data, for those of you that don't know it, this is 1 month of New York taxi rides. In this case, it's 2023 January. You can see the file is half a gig, more or less. And let's just start with one. The data is now inside. It's there now. I can analyze it now.
So the data is fully loaded into browser.
Yeah, and interestingly, it's not loaded into DuckDB, but I can talk about the detail in a bit. But let's first just analyze this. So I have here the generic count, and here we have 18 million something rows in the browser, and of course we can start and pivot that. Now, if it gets larger, well, I can go there in a second. But so I mean, okay, we can take the request, do the same thing, add the year, and that's going to be not that interesting because it's just 1 year anyway. Okay, and let's get the month name as well. Also this gives you a feel, right? For this is what 20 million rows looks like. Yes.
What's the memory usage for this browser?
300, 400 meg.
It's less than Jira.
Sorry?
Less than Jira.
Less than Jira, yeah. It's less than a lot of websites, less than a lot of React websites as well, yeah. Now, the thing is, the trick here is that, well, I said before, right? If you see something that's nice, it's because DuckDB is nice. This is the case here, because what happens under the covers is, I see a couple of, SQL, DuckDB web IDEs floating around on the internet now, where people, you can acquire the data set, the Parquet, and what those products do is they first start to actually create a DuckDB table and load the data inside. And that's not clever. You shouldn't do that. I don't do that. And the reason is that what happens here is the DuckDB WASM interface has a method called register file, and that is basically there because the WASM world does not know about your local file system at all. It has its own little file system-ish thing. And what happens is, as a user, I pick a file with the the browser interface, and then that file gets handed to you with the standard browser web file API, which is basically a blob. And you call register file, and then you give it the blob, and then DuckDB has a name for that blob. So you can then refer inside DuckDB SQL to that file. That's what the register does. And the thing is, it stays a file. So it's registered as a file, but it does not get processed until you actually do a query on top of it. And that's what happens when you actually run it. For example, this, let me show you. If I export, and I export the SQL for this, let me get this in the clipboard. Export. It's already there. Let me just paste it. This is what gets executed on the other side. So we execute read Parquet, this Parquet file. So only when we actually execute this thing does DuckDB actually go into the Parquet file and start, grabbing the data and start doing things. If we start applying filters to it by adding a where, DuckDB actually pushes down the condition into the Parquet reader to get the data from Parquet. Now we're only looking at half a gig, right? Just 18 million rows. But we can, of course, extend this. We have more taxi data. So we can say, okay, we go back to the data sources. We see two data sources, right? The one that we started with, the LA City flight stuff, and then the taxi data. And they're just files. And they're different files. I mean, we see different icons to indicate that one of them is CSV, the other one is Parquet. Now we add more. And let's just add a bunch, right? And just take half here. The other ones as well. Well, they're all more or less the same size. So now we've got 3 gig of Parquet data. And what you see here is that we get all the individual ones, and we can analyze an individual one. So if we now go to this one, for example, or better yet, we notice that the column layout of all these things is more or less the same, right? So that's why we bucket them, and we can analyze the bucket with all of them, or we can analyze one of them. And over here also notices that. So we've got because the same query could be satisfied with either of these files, we don't lose our query. We can now just apply the same query on February. And okay, this will take them a little while, but okay, so 6 seconds, right? If we do the entire bucket, then I think I will have to, I have to do it again. But let me just do that. Okay, I'm just going to put auto query off for a while, so I can just add these things, put them on the columns, and then do the request, date, and then year, and then month name, and then, I don't know, week. And then we run it. This is going to take, a while. So I've got I think a 16 gigabyte ROM. It's an HP Ultra book, so I'm not sure exactly the processor, but I've got like 4 cores, something like that. But there's a thing about so DuckDB can actually use that. DuckDB WASM cannot, because WASM has a 4 gigabyte hard memory limit, and it can also use just 1 thread. So that's so outside the browser this would be better. Yeah. So now it's beginning to come back. So it's like it takes a minute. Yeah. Okay. So you have to wait indeed. But let's put it this way: 3 gig without DuckDB would not be doable, right? So this is pretty much the practical limit what you can do. But the upload is quick. So as long as your queries are on highly aggregated, it's going to be quickly anyway. So yes, please.
As I understand it, the web file API requires you to
actually load the entire file into RAM. Is that not a limitation?
No, it's a stream. So you get a handle to the file, and it's streamable. Whether it actually materializes it or not, I don't know, but I don't believe it does because, yeah.
This you say that the browser has just file handles and reads the data on demon streams. And do you know whether browser can access data on offsets of this raw stream of files? No, not reading all the data, but reading chunks of data.
Yes. 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 So if we check the browser thing, yeah. So now it claims that the page costs 550 megabytes, which is yeah. I mean, it's Chrome, right? It always is kind of hungry. I don't think this is. I really think the data is not holding up the system now. So yeah. Yes.
Could you load it into memory instead of
Well, that's yeah. So that's a good question. You should take a look at the web IDEs that do load the data into DuckDB first, because that pretty much is that, right? If you take the Parquet file and you dump it in a table in DuckDB, the DuckDB table is going to be in memory, right? It's not persistent. So in that case, it will reside in memory, and you do notice that. You do notice that it gets slower, and so you could do it until you run out of memory, and in the case of WASM, until you run out of your 4 gigabytes of memory, or actually, sorry. That's the interesting thing. Intuitively, you would say like, oh yeah, sure, put it in memory, it's going to be faster. And I found that with Parquet, also with DuckDB like plain vanilla outside the browser, in a surprising number of cases, it doesn't really get that much faster if you first put it into memory. So if it's Parquet, probably just stick with that, and if it becomes too slow, then start doing clever things. But yeah. So yeah. Okay. Is your question a little bit answered about the size and the limits of the thing? Yeah. Okay. Good. Okay. One thing that I wanted to.
When you upload data from URL, for example, in this case, the data should be uploaded in full or
Yeah. Yeah, no, it actually does an HTTP request. Yeah, so the question is, if you load from URL, does the data actually get materialized? And the answer is yes. It cannot stream a URL. I mean, it really starts to first download that data, and then, but then of course it offers it again as a blob to the interface. But that blob will be in memory somewhere. So yeah. Okay. One other thing that I want to show is, like last year I showed that you can also load JSON, and that was true. You could load it, but it was kind of limited because you could just only see the columns that come out of it. And a column with a JSON blob inside is not that useful, right? You want to be able to get to the structure. So what I did after last year's FrosCon call was. I worked on that. Let me show you. Wait, where are we? Yeah, here we go. So I have here GitHub events as a JSON file, and this is 25 meg. It's not huge, but it's large enough to kind of show. Here what we see in the upload process is interesting because we noticed that it's a JSON file and we need to load the DuckDB JSON extension, and the uploader takes care of that. It just schedules that, and you see that as a separate progress task, basically. Now it has done that. It has loaded it all. If we go to the data sources thing, we see now that it's called large file. This is the JSON file. If we analyze it, we see again, so these are the columns that we get back, and we should think that, okay, so this is a basically a big JSON array of objects, and sorry, that's not true. Actually, we see 1, I think this is JSON line format, so a whole set of JSON objects, each with an ID, type, actor. The repo is about payload, and public, created at is a normal date, and organization. And of course, what we saw here, okay, so these are, we already saw this, text columns, just ID, just type, that's fine. And then we see these things, and those are structures. So this is a JSON object, and what happens when you give the JSON to DuckDB is that it tries really hard to discover the schema. And this is actually a really nice feature. It does take a little bit of time, but it actually goes through all these JSON stuff and tries to figure out what is what are the recurring attributes and how can we model that into a struct. And that's useful because the more information you know about the types, the more useful queries you can do with it, right? That's also, I think, the pitfall of logging stuff in JSON or using JSON as an analysis format. That, if you don't know or if you haven't documented the schema, I mean, who knows? I mean, you're only going to get out of it what you're asking for, and if it's not there, you might have an island of data that's buried in there that you never see again because you just don't know it's there, right? So this is a nice feature of DuckDB. It actually tries to find the structure in it, up to a point, right? Because it cannot, at some point, it becomes too intensive to do it, but it does a really good job of it. Now, anyway. So let's take a look at it a little bit. So the ID is just the event ID, and the type is going to be, let me put on the autoquery again. Just the push event, create event, that kind of stuff. And here we have the structures. So we have actor, the repo, the payload. Those are all structured elements. Now the actor is probably the guy who did it, who did the event. And because it's a struct, we get a new folder of structure. And what that in this case does is, this is a struct. The column is actor, but that is a struct, so that means it's composite. It has its own set of fields in there. But it's really no different than just, as if all these columns, ID, login, gravatar, and so on, would just be at the highest level, right? It's just, it doesn't change the cardinality of the data. It's just renamed in a way, right? So these things I can, with no issue, I can just add those to the query, and then it will prefix them with the place where they came from. So actor ID, actor login. You can kind of see doing it. All these users over there. We have the repo is also structured, and there is happening something interesting because there we have. Sorry, this is more or less the same thing as the actor. Sorry, I meant the payload. I'm going to talk about that. So let's get the repo in there as well. And now let's take a look at the payload because there is something interesting. The payload is again a structure, so we see the stuff inside. And here we find the commits. And the commits is an array. Now we can just show the array as an array, right? That's no problem. We can do it. But you get this stuff, right? It's not analyzable in a way. So what you want to do is, you want to say, okay, I want to unroll this array, right? I want to make rows out of the array entries. And to do that, we can use the array operations. So we can say, okay, give us the elements inside the array and the indices of the elements. So if we do that, so now we see here we have a nice example actually. So here we see this is a push request from user Walmik for this repository, and they made 1, 2, 3, 4, 5, 6, 7 commits, and these are the commit, the commit content. And of course, because the commit content is also a structure, but we can keep going on, right? We can just grab the elements of that. And if there would be arrays inside of arrays, it's just the same thing. We just unroll them again, right? It doesn't make the analysis particularly, nice, because it's always like what's now in the box now, right? But at least you can do that now, and you couldn't do that before. And of course, to make this work as well, if you have a array yeah, it needs to work on the filter side as well. So you can say, okay, I'm going to filter for an array, but I wanna use. Oh wait, sorry, that's on the element side. I should have done it on this level. Wait, let me get rid of this one. So like this. And yeah, because it's now an array, we also get a couple of array specific filter values. So include has any, include has all, and yeah, this is basically because we still want to pick individual values. Yeah, it unrolls it in the query list, and we can then pick from here, and we can say okay, give me. Well, in this case, it's a little bit complicated for this particular data set, but at least we can pick the individual elements and say, okay, find me all the instances where all of these are present in the array, or just any of them is present in the array, and that kind of stuff. I am running out of time, so if there's, I think if there's still some questions now, then this would be the moment to do that. Yes? Question is it possible to have multiple tables in the query and do lookups, right? Yeah. So right now you can't. What you can do, let me just go to the roadmap, because that's on the roadmap. The idea is to have to be able to build an OLAP model where you can have, like, multiple tables or multiple data sources in this case. Draw the relationships and then have this kind of behavior. But it would not be an explicit lookup. It would be a model, and you just pick the column, and the lookup will happen automatically because it's a star schema, right? So you already know what's going on. What you can do, though, and then you can do that today, if you know how to write a query for what you want, you can write that query, make a view out of it in a DuckDB file, and load the DuckDB file, and then you can do it like that. So indirectly you can, but yeah, to make it nice, that needs to happen still.
Is it possible to write type down query instead of?
Yeah, that's on the roadmap as well. So under the covers, it already is possible. So the data sources I have now are really. So the question is, can you write SQL as a data source?
No. Can we write SQL for data analysis in this application instead of using this constructor for
yeah. Yeah, no, so today you cannot, but there's features planned in two levels. One of them is that you can create your own attributes with whatever SQL function or expression you want to do there. So you would have then expressions as well, and then the other one would be that you take the data source and write an SQL on that. Yeah, so under the covers it's already possible because I use that for some other things in here, but it's not exposed in the UI yet. So that's something that is actually quite easy to do, but I haven't gone around to that yet.
I think that will be a nice feature because it's sometimes it's easier to type query instead of creating.
Yeah, I know. I love SQL. I type a lot of queries. I try to make the user interface so that that it would be like a last resort thing. It should not be necessary, but right now I recognize the feature request. Yeah.
Another feature request is to build graphs over time because frequently this data has time ordered, timestamp column, and it would be great to see some bar charts or graphs over time.
Yeah, so the question is, can we visualize it with something else than a pivot table? That is not possible yet. I have looked into it, and what's keeping me there is that I would need to introduce a dependency, or I would need to do it myself. I want to avoid adding a dependency because I want to keep it. We use it at customers for a couple of financial data. So this is like a large multinational where we're using it for financial data. It's very sensitive, and we would not be using Huey for that if it would have like all these dependencies, because it would be a pain to verify whether data is safe. So I want to the zero dependency thing is really a key feature that I want to stick to. So that's really what's keeping me from doing those kinds of things. I need to stop because the next speaker needs to prepare. Thank you so much for your participation. And if there's anything, find me offline and we'll talk more about it.